So number 10 is one of my favorite rational expression problems. It's a little bit complex, so just hang in there with me with the domain restrictions. The factoring is not so bad. If we look at the numerator here, we've got to recognize that that's a cube, and so this is a sum of cubes. One is just really one being cubed. So remember, the way we do that is we decide what A is. A in this case is just x. X is being cubed right here. And B is just 1. 1 is being cubed right here. And so remember the pattern for that. You can look it up. Or, oops. It's this. Just remember that if that's a plus, that first sign is a plus. So same sign, opposite sign here. And then this one is always positive. Okay, so to factor this numerator, it's going to end up being x plus 1 for a plus b, x plus 1. And then we have, we're going to have x squared minus 1x plus 1 squared, which is really just 1, right? So that's what we have there. If I want to factor this denominator, you can see first there's a GCF of x, right? So if I pull that x out, right, the first thing I'm going to do here is pull the x out, one of the x's out. So that leaves me with x squared minus x plus 1. Right, that's what I get if I factor that denominator. So I'm going to put that right down here, x squared minus x plus 1 times 4x. Obviously 4x doesn't factor, and then right here it's pretty easy to see that the GCF is going to be a negative 48. And if you pull that out, negative 48 times x gives you negative 48x, negative 48 times 1 gives you negative 48. Okay, so you see right here that the trinomial part of my perfect cube that factored is going to cancel with this part right down here. So this actually all goes away. Remember, when we're multiplying, we just multiply straight across, right? So this x plus 1 can cancel this x plus 1. This x can cancel this x, and so I'm just left with 4 over negative 48. You can divide both numbers by 2, and you get negative 2 over negative 24. You can divide them by 2 again, and you get 1 over negative 12. So this is the answer. And I think I told you in class the answer on the back is actually incorrect because it's not this, but I had already made copies when I realized it. So this is the correct answer in the video. Now for the domain restrictions. Even though all the denominators canceled out except for the number 12, we still have restrictions from what these things can't be. So first of all, right here, this can't be 0, because you're not allowed to have a 0 in the denominator. So x is not allowed to be 0 because of that. What would make this equal 0? What plus 1 equals 0? Well, that would be negative 1. Or you can set x plus 1 equal to 0 and you can solve it, and you get negative 1, which means that x can also not equal negative 1. Okay, and then this is going to be a little trickier because it's a quadratic, and it's a quadratic that doesn't factor. So I want to figure out when this does equal 0 so that I can restrict those domains. So to solve this, if it doesn't factor, I have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac. And you notice here that all of your values, a is 1, b is negative 1, and c is also 1. So we just have a bunch of 1s here. Negative, negative, so positive 1. Negative 1 squared is positive 1. 4 times 1 times 1 is 4. So I end up with this, right? And remember, the negative can come out as the letter I. So this is really just 1 plus or minus I root 3 over 2. So these two numbers, right, 1 plus I root 3 over 2 and 1 minus I root 3 over 2, these are also restrictions on the domain. So this is what x cannot equal. Right, so there are your domain restrictions. There's the answer to your problem with those domain restrictions. You're not going to be expected to do one like that, but I wanted to show you that that can happen.